light. It's just everywhere, right? We kind of take it for granted. But what if I told you that this thing we see every day is actually a cosmic messenger? That it travels across the vast emptiness of space to, paint our world and reveal its deepest secrets? Let's pull back the curtain on the invisible universe that's all around us, thanks to light.
Just look at this. The incredible, vibrant life of a coral reef. That brilliant orange on the fish, the deep, deep blue of the water, every single color, every shimmering little detail is a story being told by light.
Okay, now for something completely different. This is an X-ray, right? It's peering right inside a person's body, showing us a pacemaker. Now, this is obviously not the gentle, warm light from the sun. It's a powerful, penetrating force. But here's the part that'll bend your brain a little. It's the exact same fundamental thing as the light that makes that coral reef so beautiful.
So, what's the deal? How can that be? What single force of nature connects the beauty of a reef to the power to see through our own bodies? The answer? Well, it's going to open your eyes to a universe that's been hiding in plain sight.
And the answer is the electromagnetic wave. That's it. That's the big secret. From the gentle warmth you feel from the sun to the crazy power of an X-ray, it is all the same thing, just wearing a different outfit.
So what on earth is an electromagnetic wave? Well, the easiest way to think about it is like a ripple, but not in a pond, a ripple in the very fabric of the universe. It all starts when an electric charge just wiggles. That little wiggle sends out these two connected fields, one electric and one magnetic. They kind of dance together as they zip through space.
And this picture shows that dance perfectly. You've got the electric field here in blue going up and down. And then you have the magnetic field in red going side to side. Now here's the crucial part. They're always at right angles to each other, and they're both at a right angle to the direction the wave is actually going. They're like this self-sustaining team, pushing each other forward.
But that's just the basic building block. That one simple wave is the key to an entire family of light, a whole spectrum of different energies that literally shapes our world in ways we can barely even imagine.
So here it is, the whole family portrait of light. Over on one end, you have these super long, kind of lazy radio waves. As we move across, the waves get shorter, more packed together, and way more energetic. You go through microwaves, infrared, and then you see that tiny little sliver of rainbow? That's it. That is our entire visible world, everything we've ever seen. And beyond that, you get into the really high-energy stuff, ultraviolet, X-rays, and the unbelievable power of gamma rays.
Now here's the fundamental trade-off, and this is super important. Think of it like a spring. When the wave is long and stretched out, it has a low frequency and, not much energy. But as you start to squeeze that wave, making the wavelength shorter and shorter, the frequency goes through the roof, and boom, so does the energy it's carrying.
And this is where it all comes together. Because that simple relationship between how long a wave is and how much energy it has, that is the secret sauce behind almost all of our modern technology, from your phone to life-saving medical gear.
Let's just do a quick tour of this spectrum in our daily lives. Radio waves, they carry our favorite songs. Microwaves, they literally make water molecules vibrate like crazy to heat up our food. Infrared, that's the invisible warmth you feel from a campfire. Then on the high-energy side, you've got X-rays giving doctors a window inside our own bodies, and gamma rays, which are so powerful they can be used to fight cancer.
All right, let's zoom back in on that tiny sliver of visible light and talk about the magic of color. It seems so simple, right? But the way we see the world is this fascinating trick of physics and biology all working together.
So on the left, that's what happens when you mix paint, like in art class. It's called subtractive color because the pigments absorb or subtract certain colors. You mix them all up, and you get that muddy blackish color. But light is the complete opposite. It's additive. The primary colors of light are red, green, and blue. And when you mix them all together, you get pure white light.
But here's a pretty humbling thought. The way we see color, it's not the only way. It's not even the right way. Our eyes have 3 types of color receptors. Dogs only have 2, so they see a much more muted world. And bees? Get this, they can see into the ultraviolet part of the spectrum. They see patterns on flowers that are completely invisible to us. They're basically seeing a hidden layer of reality.
And that leads to a fun fact. Because most mammals that aren't primates, like dogs and, bulls, are red-green colorblind, that whole idea of a bull getting angry at a matador's red cape, it's a total myth. It's the waving motion that gets their attention, not the color red.
they can barely even see it. Okay, one last mystery to solve about light. It's something you might even be wearing right now. Let's talk about the secret behind polarized sunglasses.
So the light coming from the sun or from a light bulb is pretty much a chaotic jumble. The waves are vibrating in every single direction. Polarized light is the exact opposite. It's light that's been organized, filtered so that all its waves are vibrating together, perfectly in sync on a single plane.
This little analogy makes it super easy to understand. Imagine you're shaking a rope up and down. That vertical wave, it passes right through a vertical slit, no problem. But now try to get that same up and down wave through a horizontal slit. Nope, it's completely blocked. A polarizing filter does that exact same thing, but for light waves.
And here's the payoff in the real world. When sunlight reflects off a flat surface, like water or a road, it becomes horizontally polarized. That's what we call glare. Well, polarized sunglasses have vertical filters, just like that vertical slit for the rope, and they simply block that horizontal glare. And look at the difference. The glare vanishes, and suddenly you can see the rocks right under the water.
So, what's the big takeaway from all this? It's that light is so much more than what we see with our eyes. It's this vast, invisible ocean of energy all around us, powering our world in countless ways, from the miracle of a plant growing to the very technology that connects us all.
So I'll just leave you with this question to chew on. If our eyes could suddenly see the entire spectrum, what would we see? What incredible new colors, what hidden realities would suddenly be revealed all around us, every single day?